Ever get that itch? Like you just need to know the why behind, well, everything.
Oh, absolutely.
Like what do scientists actually do when they study, say, rabies?
Yeah.
Well, you and this deep dive, we're on the same wavelength because we are diving headfirst into Reddit's Ask Science.
Oh, it's amazing, isn't it? That corner of the internet where you get raw curiosity meeting, the minds that dedicate their lives to finding these answers.
Yeah, it's like a peek behind the lab curtain.
Exactly.
I've got a stack of listener-submitted questions pulled straight from those Ask Science threads, and let me tell you, some of these are out there.
Oh, I bet.
We're talking magnets, hurricanes, even comet tails that seem to break all the rules.
Well, that's the beauty of it, isn't it? It's that often the questions that we think are very simple,
Right.
that unearth the most mind-boggling scientific concepts.
Speaking of mind-boggling, someone asked if magnets get stressed when they attract or repel. I mean,
It's
it takes effort, right?
It's a fair assumption, right? Because we tend to think of effort as requiring energy. And in our, day-to-day lives, that often holds true. But here's where the world of magnets throws us a little bit of a curveball.
Okay.
You see, a magnet in its natural magnetic state, so to speak, is actually already at its lowest energy level.
Hmm.
So think of it this way. Attracting or repelling isn't like work for a magnet. It's more like a sigh of relief as it settles into, its most relaxed state.
So magnets are just out here living their best low-energy lives. Okay, that's one way to look at it. But while you're on the topic of unexpected chills, someone else asked about Hurricane Helene
Okay.
and where all that floodwater goes. It really makes you think about the bigger picture.
It does. And I think, we often focus on the immediate impact, but that question highlights something really crucial, which is the interconnectedness of, natural systems.
Right.
That flood water from Hurricane Helene, it doesn't just vanish, right?
Right.
It embarks on a journey. It becomes part of this massive cycle. It might replenish groundwater systems miles away. It might eventually, find its way back into the atmosphere, influence weather patterns in ways we might never imagine. It's a powerful reminder that even seemingly isolated events can have these far-reaching consequences.
Okay, now I'm picturing Hurricane Helene's floodwater on like a cross-country road trip.
Yeah.
So from magnets defying stress to hurricane water on tour, are you ready to tackle some of these other Ask Science gems?
Absolutely. Where do we begin?
Well, there's a question about comet tails that really caught my eye. You know how they usually point away from the sun?
Right.
Someone wanted to know if they could ever point towards a star.
Ah, yes. The curious case of the anti-tail. Let's unravel that cosmic mystery.
Okay, so comet tails, I get it. They're like cosmic wind socks, right?
Right.
The sun blows, the tail streams out behind. How could it ever point the other way?
Right, yeah, that's the usual picture. It all comes down to the sun's heat and solar wind.
Right.
So as a comet gets closer to the sun, ice and dust vaporize off its surface.
Hmm.
And that stream of charged particles from the sun, that's the solar wind,
Okay.
pushes it all into that long, dramatic tail that we see. But as with most things in space, there's a twist.
Hit me with it.
All right, enter the anti-tail. Now, it's not really a tail pointing the wrong way. It's more like a trick of perspective.
Okay.
So imagine a comet shedding dust, kind of like a trail of breadcrumbs, if you will.
Okay.
This dust spreads out, right? It forms this slightly curved sheet. Now, depending on where the Earth is in relation to the comet and the sun, that sheet can appear to point towards the sun,
What?
even though the individual dust particles are still being, blown away from it.
It's like one of those forced perspective photos, but
Mhm.
on a cosmic scale.
Exactly. It's a great example of how our viewpoint, our perspective can shape, what we observe, even when we're talking about space.
Yeah, wow. Okay, so from cosmic illusions, let's zoom back down to Earth,
Right.
or at least to our kitchens.
Mhm.
We got a question that, frankly, speaks to my love of leftovers.
Yeah.
Can bacteria actually become resistant to cold, like in our fridges?
Ah.
Because that's a chilling thought, to say the least.
Right. Yeah. It's a question that's very relevant, I think, to our anxieties about antibiotic resistance.
Right.
But here's the thing. Cold temperatures and antibiotics, they work very differently, right?
Oh.
So when bacteria develop antibiotic resistance, it's because of, genetic changes that let them survive the drugs attack. Cold, on the other hand, doesn't attack in the same way. It slows down their metabolism, essentially putting them into a state of almost like suspended animation.
So more like a forced hibernation than like a battle royale.
Precisely. They're not being like killed off, just put on pause, so to speak. Now, the original question, does bring up an interesting thought. Could bacteria over a long, long period evolve ways to be more active in the cold?
Okay, now we're getting into sci-fi territory.
Well, it's important to remember that, evolution isn't goal-oriented.
Right.
It's about adapting to the environment.
Right.
So while it's theoretically possible for bacteria to evolve to thrive in, colder conditions over millennia,
Okay.
it's not something we need to worry about anytime soon or stock up on extra fridges for.
That's a relief. Now, before we move on, didn't we have a date with some slightly concerning lab work?
We did.
Specifically, the ins and outs of rabies research.
Yes, yes. And it's a fascinating glimpse into the world of, I guess you could say, controlled chaos that is scientific research.
So how do you study something like rabies without, turning it into like a full-on horror movie scenario?
Right, right. Well, it's all about layers of safety, meticulous protocols. Scientists working with the rabies virus, they do so in these specialized labs,
Okay.
equipped with multiple levels of containment.
Oh,
These labs are designed to, prevent any accidental release.
right.
Kind of like I guess you could say like high security vaults,
Right.
but for viruses.
So less breakout,
Yeah.
more carefully contained for scientific study.
Exactly, exactly. And on top of that, they often work with, weakened or inactive forms of the virus,
Oh.
which are much, much safer to handle
Right.
while still allowing for, valuable research.
Right. Yeah.
Think of it like studying an animal's tracks.
Right.
Instead of like coming face to face with it in the wild, you
Yeah.
can learn a lot without, the immediate danger.
Right. Right. That makes a lot of sense. It's a good reminder that, research on these potentially dangerous things is ultimately about, protecting us. Right?
Yeah, exactly.
Okay. So before we officially sign off from our Ask Science adventure, were there any other questions that kind of like caught your eye from this batch?
Oh, there were so many. Someone asked if it was possible to extract memories from a brain,
Whoa.
which sparked this whole discussion on how memory even works in the first place.
Right.
And then there was the one about why Velcro makes a noise when you pull it apart. Simple, everyday stuff,
Right.
but with a whole lot of science behind it.
See, this is why I love digging into these questions. You never know what seemingly, ordinary thing is hiding a universe of fascinating details.
It goes to show the world is full of wonder if you just know, where to look, or rather, what to ask.
Couldn't have said it better myself. So, to our listeners out there, next time you encounter something that piques your curiosity, no matter how small, don't ignore it. Ask that question. Dive deeper. You never know, you might just uncover something truly remarkable. Thanks for joining us on this Ask Science Deep Dive, and until next time, stay curious.